Hello students. Now in general organic chemistry, now in the next lecture, in the last lecture we are discussing the nomenclature rules for saturated hydrocarbon, that is for alkenes. Now in today's lecture we are discussing nomenclature for unsaturated hydrocarbon, that is alkene and alkynes. So let us revise what are the basic rules that we are using in case of the nomenclature of saturated hydrocarbon, that is alkenes. The basic rules are the first we select we use a longest chain rule. So according to the longest chain rule, we are selecting the longest continuous chain containing the carbon-carbon single. Then second rule is the lowest locant number. Locant is the number which indicating the position of the such alkyl groups. They are not come in your continuous chain. So that number is called as the locant number. So we are giving the number to the chain in a such a way that the branched group or the alkyl groups will be got a least possible number. Then we are considering what are the alkyl groups. Now if they are identified, if the alkyl groups are the same, then we use the prefix di, tri, tetra. If the alkyl groups are the different, then we are identify them and we are arrange them according to alphabetic order. And the last one that we are write the name of the alkenes in a single word by using a comma in between the two numbers. Suppose we have the 2,2-dimethyl, then we are using a 2,2 in between the numbers. So 2,2-dimethyl heptane is such a compound. Then here we are using a comma between the two number, and between number and the word or letter we are using the dash, and dash is called as a hyphen. So what are the four basic rules for nomenclature of the aliphatic saturated hydrocarbon, that is alkenes? First is the longest chain rule, then the lowest locant number, identify and name the substituent, and write the name of the compound in a single word. We are writing the name in a single word using the comma and hyphen. So this is a common rule for the nomenclature of alkenes, that is the saturated hydrocarbon. Now here we are discussing the nomenclature of unsaturated hydrocarbons, that is the alkene and alkynes. So for which the rules, some basic rules are as it is, some changes in the rules are only. So the first is the longest chain rule. So in the longest chain rule, we have to select the longest continuous chain containing the functional group. Now here alkane have the no functional group, but alkene and alkyne have a functional group. So we have to select the longest chain rule, in which we can select the longest chain so that it contain your multiple bond. Means that multiple bond is that multiple bond must be there. That must be have a carbon-carbon double bond or carbon-carbon triple bond. So these multiple bonds present, that chain we can select it. For example, if I consider a longest chain like this way. Suppose I have the example like this way. Okay. Suppose I have to select the longest continuous chain. So in alkane we consider this chain is the longest continuous chain. It is alright. But here we are considering the alkynes. So in the alkynes we are not selected this chain as the longest, though it has a 1, 2, 3, 4, 5, 6, 7. There are 7 number of the carbon. But if you consider this, it has a 5 number of the carbon. Okay. But we have to not selected this chain is the longest chain. We have to selected this chain because it is the longest and it contains the functional group. So our chain is now 1, 2, 3, 4, 5, 6 and 7. Now your longest chain we can select it that containing the functional group as a double bond or a triple bond. So what is your first rule? The longest chain rule. Select the longest continuous carbon chain containing functional group, your multiple bond. That multiple bond may be double bond or the triple bond. As this chain will have no multiple bond, this is not a longest chain rule. Okay, so this is not a longest chain. The second is the Now once you select the longest continuous chain, now identify the parent for them. So it is as the longest chain is of the 7, so its parent is a heptane. Its parent is a heptane. Now in the case of the multiple bond, the second rule is that change A and E of the alkane for the E and E. So at the place of A and E, we use E and E or Y and E. If you have the double bond, we can use E and E, means A can be changed by E, or the triple bond can change by Y and E. So like this way, a change can be made, that is the heptane. A and E can be changed by E and E, or A and E changed by the Y and E in the case of the double bond or the triple bond. In the case of the double bond, we use E and E. In the case of the triple bond, we use Y and E. So first the longest chain rule, then change A and E by E and E or Y and E depending upon which multiple bond we have. The next rule is that now we have to give the numbering to the rule. We have to give the numbering to the rule. So to the chain. So numbering is given in such a way that the multiple bond will be got the least possible number. Now we have to give the numbering in such a way that multiple bond will be got the least possible number. Suppose we have the example like this way. Suppose consider this example. Now select the longest chain. We have the no choice, only one chain is there. Now this 1, 2, 3, 4, 5, 6. So it has a heptane as a parent. It is a 6 carbon. But it is so. What are the compound is this? This compound is a derivative of heptane. So as it has a triple bond, I change A and E by YN. I can change A and E by Y. Now second rule is the lowest locant number. Now give the numbering to the chain so that your functional group will be got least possible number. Suppose I go from this 1, 2, 3, 4, 5 and 6. So this is a multiple bond, and in this multiple bond, if you go from this side, the least number is the 4. But if you go from this side, 1, 2, 3, 4, 5 and 6. Okay. So it is a 6 carbon, so it is a hexane. So its parent is a hexane, and we can consider is a hexene. Sorry again. So the total carbon are the 6. So hexane and your hexane. Okay. So you can go from this side. What is your number? 2. 2 is the minimum number. So this double bond, triple bond will be has a number as a 2. So it is a hexane. And repeat this. It has a hexane. So which number is the now? What is the second rule? Lowest locant rule. So according to the lowest locant rule, if it go from this side, means from the right side, it has a number 4. But if I go from this side, it has a number 2. So which is the lowest number? 4 or 2? So 2 is the lowest number. So this number will be indicated before your parent. So it has a hex 2 Y and E. So it is a hex 2 Y. Now similarly consider this. Now it has a total 1, 2, 3, 4 and 5. So pentane is the parent. But it has a double bond. So change A and E by change A and E by E and E. Okay. Now give the numbering so that double bond will be got least possible number. So if I go from this side, it has a number 4. But if I go from this side, it has a number 1. It has a number 1. So which is the least number? So of course 1 is the least number. So I write its name is a pent. Means it has a 5 carbon. For 5 carbon root word is a pent. It has a double bond at 1. So 1 En. If you not write 1, then it will assume that it is 1. But if you write it, it is the correct also. So it has a pent. 1 En is the name. Okay. So again we will repeat. So what is your first rule? Long edge chain rule. Select the long edge chain containing your multiple bond, that is a double bond or triple bond. Then give the numbering so that multiple bond will got the least possible number. So once you select your root word, then change ANE by ENE or YNE. Okay. Then place the local number which indicating the position your multiple bond, that is indicating the position of your double bond or triple bond. That number is placed before your root word. So here I place as a 2 or here I place as a 1. So whatever the number that indicating the position of your double bond or triple bond, that is multiple bond, that number, that is local number, you have to place before your ENE or YNE. So these are the 4 basic rules. Now next is the, suppose you are while giving the nomenclature of organic compound, if the tie is made or if the multiple bond is at the equidistant position, suppose like this way. In this example, suppose you consider example number 1. In example number 1, if you give the numbering from this side, from the right hand side, your multiple bond has a number 3, and from the left hand side, the multiple number has a 3. So which side now you have to prefer? So in this case, we have to prefer a numbering from that side so that your branched group, these are the branched group, the branched group will be got a least possible number. Your branched group will be got a least possible number. So if I go from this side, it has a branched group has a number as a 3 and 5. The local number is a 3 and 5. But if I go from this side, 1, 2, it has a 2 number and it has a 4. So local number is a 2 and 4. So what is the lowest? What is the sum? So sum is the local sum is the 8. Here local sum is the 6. So who is the lowest sum? So 6 is the lowest sum. It is the highest sum. So we are preferring the lowest sum of the local number. And therefore, if the double bond is equidistance from the both sides, from this side the double bond is at the third position, from this side double bond is also at the third side. So here the multiple bond is at the equidistance. At that time, the number is given in such a way that the branched alkyl group will be got a least possible number. So our numbering system is now 1, 2, 3, 4, 5 and 6. So if you consider like this way, so it has a parent as hexane. It has a parent as hexane. Now change the ANE by ENE. Okay, and the position of the double bond is a 3. So I place hex 3NE. So it is a, I can write it has a hex 3ENE. Okay, and again there are the 2 alkyl groups at the position 2 and 4. They are the 2 and they are identical. So I write 2, 4. I can write 2, 4 dimethyl. What its name now? 2, 4 dimethyl hex 3. Now in this case, now look here. So again, if I go from this side, from the right hand side, the triple bond is at the 4th position. From the left hand side, the triple bond is again at the 4th position. So again, your multiple bond is equidistant from the left or right hand side. So in this case, a numbering is given in such a way that if it has a branched alkyl group, now it has a branched alkyl group. So give the numbering so that branched alkyl group will be got the least possible number. If you go from this side, it has a 2 number. But if you go from this side, it has a 5, 6 and 7 number. It has a 2 number. So 2 is the lowest. So we are preparing the side so that it has a lowest possible number. So now in this case, what is the name of this compound? So it is a 2-methyl. 2 and methyl has a dash. Then it has a parent 8. So it is a octane is the actually, but it has a triple bond. So change ANE by YNE, and the numbering which is showing is a 4. So it is a, I write here 2-methyl oct 4-YNE. Its name is a oct 4-YNE. So like this way we can consider in the case of the equidistance. If the equidistance is the compound, in this case the numbering is given so that the branched group will be got a least possible number. I again repeat, first is the longest chain rule. Select the longest chain so that multiple bond will be got least, multiple bond will become in the longest chain. Now give the numbering so that multiple bond will be got least possible number. Change ANE by either ENE or YNE. The number which is indicating the position of the multiple bond will be placed before your ENE or YNE. If the tie is made in between if the tie is made, in this case we have to give a numbering from the side so that your multiple bond will be got least possible number and your alkyl group also got a least possible number. Then the next is that if your compound contain 2 double bond or 3 triple bond, then in this case we have to use a prefix as a diene, triene or di-YNE or tri-YNE. If you have the multiple bond, in the 2, multiple bond, double bond is a 2 or triple bond is a 2 or multiple bond is a 3 times. For this let us consider example. Suppose example is this. Suppose this. Here there are the 2 multiple bonds, or if I consider example like this. So here you observe there are 2 double bond, here 2 triple bond. So how they give a numbering? So rules are set. Give the numbering so that multiple bond will be got least possible number. So like this way. So it has a parent as a 6, that is a hexane. Again the multiple bond is at one number 1 and 2 and 3 and 4. So in between 1 and 2, 1 is a minimum number. In between 3 and 4, minimum number is a 3. So I take the minimum number. So it is a hex. Okay. Again hex has a position of multiple bond is 1 and 3. So hex 1, 3, it has a 2. So I say it is a diene. It is a diene. Now here again give the numbering so that triple bond will be got least possible number 1, 2, 3, 4, 5 and 6. So 1, this is again it is a 4 minimum number. In between 4 and 5 minimum number is 4. In between 1 and 2 minimum number is 1. So it is a hex again, but triple bond is at 1 and 4. So hex 1, 4. They are 2. So di, and they are triple bond. So they are hex 1, 4 di. So here one change I have to again made, that is very important to remember. So the parent is hexane. If I write this way, it is wrong because I will not consider important thing, that is in writing if your double bond is a 2 time or triple bond is a 2 time, in this case the A I have to retain, the A will be not cancelled. So here I have to write hexa 1, 3 diene. Here I have to write hexa 1, 4 diene. So that is a very important change that you remember, that is A we have to retain, A have to not omitted. A will be not omitted because the same double bond or same triple bond will come in the multiple proportion as a 2 or 3. Here in this case A can be retained. So that is again important change. Suppose we are considering the example in the case multiple bond will become, suppose double bond or triple bond is come, then give the numbering so that your multiple bond will be got a least possible number. Suppose I consider example is like this way. So we are taking a simple example. Suppose I have this example. Now here I have the triple bond and the double bond. So numbering is given in a such a way that whatever the multiple bond will become first will be got a least possible number. So this is a 1, 2, 3, 4, 5, 6 and 7. Because if I go from this 1, 2, it has a 3 number, 4, 5, 6 and 7. So now what are number? It has a number 1 and 4. It has a number 3 and 6. So 1 and 4 is a 5. 3 and 6 are 9. So we are not preferring this side. So we are preferring this side. So now we have the multiple bond. But remember, though we have the multiple bond, it has a double bond and triple bond, both will become. We are giving the numbering so that the multiple bond will be come first, will be has a minimum number. But when you write the name, we have to write ENE first and then YNE. So what is the name of this compound? It is a heptane, is a parent, right? In the heptane, the heptane, E can be written A. Now double bond is position is a 4 En. Triple bond position is a 1 Yne. Okay, so it is a hepta 4 in 1 Yne. Okay, though the triple bond will come first and double bond will come later, but while writing we are write first double bond and then triple bond. So let us consider one more example. Suppose here I write example. Okay, suppose I have an example like this way. So in this case, I have to consider the nomenclature. So use the numbering so that whatever the multiple bond will be has a minimum number. So it is 1, 2, 3, 4, 5, 6 and 7. If you go from this side, 1, 2, 3, 4, 5, 6 and 7. So from this side number is 1 and 4. From this side number is a 3 and 6. So 3 and 6 is greater, so I cancel. What is my proper number? 1, 2. So look, in this case, the triple bond will come first. In this case, the double bond will become